Okay, so yesterday I introduced, now that we know how probability is stated, how odds are stated, how we go from one to the other, between odds, right? Odds for, odds against. We're going from probability to odds, odds to probability. This is page 15. And now you're going to encounter the situations where you may have to use perms and coms or fundamental counting principle. Okay, so that's all fair game. In my opinion, by the time we get to the exam, you will have a pretty good idea. Oh, this is totally comms, right? We're making teams here, we're making committees, or this is perms, right? I need to use permutations here. What is happening, right? So let's go, and we did something with combinations yesterday. Now we're going to go to page 16 and try some other ones. Okay, so John, Ethan, and Adriana are competing with 10 other runners in a cross-country competition. If all runners have an equal chance of winning, determine the probability that John, Ethan, and Adriana will win first, second, and third place in any order. Well, let's get our total out of the way here. If it's these three and 10 others, we've got a total of 13, right? We have specific positions. Will order matter, you think? So, yeah. Order matters. Okay? We can use perms or fundamental counting principle. Okay, so you can use that as you wish. I feel like for most of you, NU is going to be the easiest to start with. If you get your universal right, you know that everything else needs to be smaller, right? The top number needs to be smaller. So let's start with universal. I don't go equals, I just tell everybody that's where I'm going to do my universal up here. So we have first place, second place, and third place. If everybody is involved, if all 13 are involved, then it stands to reason that it'd be 13 to start that could get first, 12, and 11. You could use permutation. What would that be? 13, pick 3, right? Let's go find that number. Or you go 13 times 12 times 11. With these calculators, it's actually probably faster to do that. 17, 16. These are all possible ways to get first, second, and third if all 13 are involved. This is what we did in chapter 4 a lot, right? But now we're focused on NA. So we want first, second, and third place. And what is now the specific restriction? Like, who do we want in the top 3? We want John, Ethan, and Adriana, right? So we technically only have 3 for the first, 2 for the second place, and then obviously just 1 left for the first place. And it stands to reason within the context, you can't have all people, right? You can't have all 3 being first and all 3 being second and all 3 being third, okay? So this would be 3 pick 3, which is 6. So now we're ready for our probability, because remember, I'm going to highlight this part because a lot of students miss this on the exam. Like, what is this here? Ultimately, is it odds? Is it probability? Is it just asking for the number of ways? What is it asking for? It's asking for probability. So we're just going to go probability of that happening would be 6 over 17, 16. I would leave it like that because most questions are not going to ask you to state it in a different format. But if they do, you just divide it, and you get 0.0035 if I round it to 4 decimals. It's not money, so it's okay to round to more than 2. I want to round it to more than 2 because otherwise I just end up with zeros, right? Can't have that. And if you multiply that by 100, that'd be 0.35%. So this, clearly identify your final answer when you're writing the exam. Show your work, yeah, that's all good, but then at the end, make sure you, if there's lots of stuff happening, clearly identify your final answer. What if I asked you for odds? This is just an aside. If it asks for odds of that happening, right? Remember, this is A to not A. Okay. So it happening is what? 6? Yeah, 1710. I think we can just do that, right? We'll just go 1710. And if you're wondering, if you need this, just absolutely go and make a little note. But there's a subtraction happening here. Yeah. You don't have to simplify, no. As I said, if it's a multiple choice, I doubt it that they would make this complicated question a multiple choice, but then they may only show you the simplified one. 2 choices. You turn this into simplified using your calculator, or take all of the answers that they have, turn them all into a decimal and compare it to your decimal answer. That's the one, right? So you've got the options there. But they will never make you simplify as your final answer. Okay, let's keep going. This one is a little weird, but tree diagrams are very much alive in chapter 4 and chapter 5. So I will do a tree diagram again because it wasn't the greatest on the test. Okay, so I'll do that one more time. With a little curve as well. Fiona tossed 5 coins. The first 2 coins landed on tails. Determine the probability that the other 3 coins, to have at least 3 tails. How does that work? Okay. We've got what happens at first. We've got the first are tail and tail, right? There's no denying that. The first 2. So there is no branching. There's no branching. So after that, that's when something happens. This is the 3rd coin. It's heads or tails. Those are your only 2 options. This is the 3rd coin. Heads or tails. Heads or tails. And then another, this is the first coin, the 2nd coin, the 3rd coin, the 4th coin, and then the 5th coin. Who's listening to music? Can we turn that down, please? It's probably a good tune. Because then I start dancing and now you're in trouble, right? You're like, can't unsee that, right? Anyways, so this is what I would like you to, in my opinion, especially when it comes to probability, write out your outcomes. So for all of these tails here, guys, I shouldn't use tails because heads or tails, right? For all the outcomes, the first 2 were tail, tail. That is for all of these branches that we're going to end up, we know that the first 2 coins landed on tail, so that is not even a question. Okay? The rest is now what you need to watch out. So heads, heads, heads. If you follow this branch, all 3 remaining will land on heads. So you remember there's 5 coins, and this is the outcome. This is one of the outcomes. The next one is what? Heads, heads, tail. Head, yeah, HHT, yeah. How about that? That's so much easier, thank you. And then it's HTH. And then it's HTT. And then now we're going down this one, THH. THT. Then it's TTH. And then the last one is all tails. So you always have the extreme, right? Extremes on the ends, right? But there's only one case that has all tails. I hope you know that one, right? Is there a case where you have all heads? In this case, it's not happening because of our scenario here. But how many do you have here? 1, 2, 3, 4, 5, 6, 7, 8. Do you think you could come up with that fact that there's 8 outcomes without doing a tree diagram? I don't know. You tell me. You tell me. Well, remember this. How many coins are we tossing? 5. But the first 2 are tails, right? So there's only one option, one option. You have heads or tails, heads or tails, heads or tails. Okay, so there's 2 times 2 times 2. 1 times 1 times 2 times 2 times 2 is 8 outcomes. And there are 8 branches here, so we know that it's 8. We're doing good. Okay. However, now it's probability. Okay, now I come along and just make it even more complicated. If it's probability, you want to stack 2 numbers. What is my condition here? You want at least 3 tails. So I'm going to use a color here. What does at least 3 mean? 3 or more. Okay, that's what at least 3. So if you need to rewrite this, 3 or more tails. If you want at least 80% on this in this course, you want 80% or more, right? Like that's just like try to think of it that way. So 3 or more. Does this one have 3 or more? Yes. Does this one have 3 or more? Sorry. I'm thinking heads right now. My head is not working, obviously. My bad. At least 3 tails. I thought I wasn't going to use this anymore, but obviously, good thing that I kept it handy. Yeah. At least 3 tails. This one doesn't work. This one works because you've got 3 tails there. This one works. You've got 3 tails. You've got 4. You've got 3. You've got 4. You've got, yeah. If it's at least 3 tails, you just count the T's. Yeah, the wording is terrible. I agree with you. So I'm going to make an adjustment here. What's the probability of hold on, I'm getting there. I'm just making sure I don't of having at least 3 tails. That's what I'm trying to say here. This has to go. There's a probability of having at least 3 tails. My bad. So we just want to make sure that in total we have 3 or more, tossing all 5. Okay. That's my bad. Like I just didn't word that one correctly. So we basically just scanned all of it and we identified all the ones that have 3 or more tails. My apologies for that confusion. This is what I would consider NA. Okay, the number of instances would be 7. The whole thing is NU, which is 8. Okay? So in this case, the probability of having at least 3 tails as your outcome would be 7 over 8. That's it. Does that solve the problem? We already have problems. I add more problems. So. Okay. What about this one? What's the probability of at most one head? I know it's not the correct way of saying it, but I hope you understand that. At most one head, what does that mean? At most one. In our context, it's 0 heads or 1 head, but no more. Okay, so we're okay to have like 0 heads, 1 head, but we cannot have more than 1. So I'm gonna highlight it this way. So let's go find them. So this one is okay. This outcome right here is okay. It has only tails. We're okay with that. This one has 1 head right there, 1 H. This one has 1 H there. This one has 1 H. This one has 2, right? So that's not good. This one has 2, and this one has 3. So it's only the orange ones. So 1, 2, 3, 4. Okay. So in this case, we're still looking at 8, but there's only 4 outcomes that we're after. Okay. So that would be 1 over 2. So tree diagrams are great at just visualizing your outcomes, right? You don't have to like guess or anything like that. And I'll say this, coins, right? Coins are female, male, anything like that, like binary like that is the easiest is to do your tree diagram if you're not sure, okay? Okay, I think I want to do one more, I promise one more, and then we're done, okay? And then you're going to fly solo. I'll walk around and help you out if you're stuck. In a contest, there are letter tiles spelling out Winnipegosis. The tiles are being turned upside down and shuffled. The contestant is then asked to arrange the tiles and turn them over. If the tiles spell the word Winnipegosis, you win $10,000 instantly. What's the probability of that happening? Let's do NA on this one. I think we gotta nail this one. What's the only way that you can win? There's only one way. You need to get it exactly like this. Like you have to have every letter exactly where it's supposed to be. So technically it's just one. One way to get them all right. It's like a test. How many ways are there to get 100%? Is to get, if it's a multiple choice, you got to get them all right. Okay, so that's basically how it goes. So let's worry about NU. Okay, universal. How do we do that? What do we do when there's a word like this? We count the total. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I count, so I'll do this on the side here, 12 letters. There are some duplicates, right? Some repeats. I count 3 I's. I count 2 N's. And is there something else? S, right? Two S's. So remember, to figure out how many ways these letters can be arranged is 12 factorial And then we need to divide out the repeats. Because whether you put the I here or there, right, the I's are all identical, so we're not counting that, right? It actually makes it a little bit easier. Your chances go up because there are fewer unique outcomes. So let's figure this out. 12 factorial. Sorry, I have to do this. I have a bad habit of not putting my, oops, it's supposed to be 12. I would strongly suggest including the in-between numbers, values, just in case you make a mistake. This is 6, so 6 times 2 times 2, that's 24. So I got 24 here. And now you're going to go 47 divided by 24. That is your final answer for universal. And now your probability. 1 way to win, and there's 19,958,400 possible ways to, if you do random, right? If you just randomly move things around, there's that many ways to randomly arrange them, okay? So your chances are not very good. Your chances are very, very small. In fact, if you go 1 divided by that, it's 5.01 times 10 to the negative 8. So the decimal will shift over 8 places, so you'll have 7 zeros before the 5 shows up. So it's 0.000000005 something. So it's a very small chance. So we don't even bother with the decimal here, okay? All right, I'm going to stop there for now. So I want you to work through pages 19 all the way to, hold on, and you might think it's a little excessive, I know that, 19 to 26, but the key, the answer key is on page 27. There's actually an answer key there, but that's just the answers. Those are just the answers. Those are not the worked out problems. I will post the key of the worked out problems as well, okay? So this is my plea to you, okay? Use the rest of today's class to work through as much as possible. If you draw a blank, if you come across a question that's just not working for you today, move on to the next one until you figure it out. There's some passwords. There's a bunch of different cases that I want you to work through. That's it for today. If you can, over the break, work through these as well. Very, very helpful, okay? Did you hear that part? Over the break, if you can work through these, very, very helpful. If you come back on Monday and you're like, Mr. Jackson, you got to explain this to me. This is like, I don't get it, right? I'm okay with that. I'm very okay with you saying you're frustrated and you're at a point where you kind of, I don't want you to lose sleep, right? Just don't lose sleep. I can fix that, but I want you to come in with questions on Monday, okay? All right, that's it.